Alrighty, so I want to actually run through this entire exam that we gave you because I know some of you are going to retake it. So I want to make sure you have solutions available too. So we have this potential difference reading, and we want to know that that we didn't zero this thing. So if we actually look at these numbers here and we take an average, the average is going to be like these numbers are not that far off from one another. So we know that they may be completely wrong, but we do know they're precise. The issue, though, is since we didn't count for the zero error, they're not going to be accurate. So that's how I'm getting precise but not accurate. Choice B for number one. Now here, this is a question of memorization. So let's just cross off non-fundamental units. Not fundamental, not fundamental, not fundamental. So we have kilograms, amperes, and Kelvin, all as fundamental units. Number three, here. So let's actually look at this thermometer. So we can guesstimate some decimals here. So we can, guesstimate. We got 6.5 as our smallest. So if you remember, our error then is going to be plus or minus half of the smallest tick mark when it's on a non-digital analog instrument. So that would be plus or minus 0.25, but we round to an even. So that's going to be plus or minus 0.2 on the reading. And if I actually eyeball this here, somewhere between 6 and 6.5, I'd say it's about 6.2 when I read it off here. Okay. Now, we want to know which of the two represent vector quantities. What's kind of nice is that I really tried to give you something where you didn't know what the stuff was. So I've never given you these or these. So you really got to choose between this and that. Now, distance is how far you go, but we don't care about direction. Acceleration, we do care about direction. Force and momentum, though, have both size and direction. So it actually turns out it's the two latest topics that we studied that are vector quantities. Now here, if we want to get a linear graph and we want to know what will produce a straight line, so there are possibilities. A versus R would. Notice this is a constant. So what would produce a straight line? A versus 1 over t squared. And then the 4 pi r would be the slope, provided r was fixed. Okay. And for number 6, now we're going into motion. So we have a graph of position versus time. And we want to know which car has the greatest speed. So we're going to go with slope here. So if you remember, greatest slope, so greatest slope means greatest speed. So that means car W, because it's got the steepest slope. For number 7, we've got a car accelerating uniformly from rest. Uniformly means steady or constant. It then continues at a constant speed, which means acceleration is 0, before the brakes are applied, bringing the car to rest, which means it will probably have a negative acceleration. So what does that tell us? That rules out this one because this is a steady acceleration here. So what do we need? We need a steady acceleration. Look at that. Followed by 0 acceleration, followed by a steady acceleration down here. So choice A. I don't like these lines here. They confuse. They don't actually mean anything when you have flat graphs like this. So this and this here, they don't mean anything. They don't tell you anything. However, that being said, choice A is the correct choice because we have steady acceleration here. Then we've got none. And then backwards steady here. Perfect. And number 8. We got V versus T, and we want to know the distance moved by the car during the time the speed is reducing. Reduced means negative slope. for reduced speed on a position graph or on a velocity graph. So from here to here, and then from here to here um, is the region that we're talking about. So the area gives you the distance. That'll be S1 and S3, and we add that up. Then number 9, we want to know. I didn't like this problem because they want to know which one tells us how the constants can be determined from the graph. So we got v equals u plus at, okay, which I'm fine with. But it seems to me that the slope will either be, the slope's going to give us a, and it seems to me that the intercept should be happening at u, not negative u. So I chose a, but I'm not happy with it. I don't get it. It seems to me that at t equals 0, v is positive u. So I'm just not, if this is a v versus t graph. I chose a. This is an IB question, and I'm not liking it. I may throw it out. We'll see. And then number 10. Variation of t, where's the speed the greatest? That is in interval A, because that is where it's the steepest. We've done a problem like that before. So that's questions 1 through 10, and I'm going to take a look at questions 11 through 20 in the next video.